the timed out duration. So by default, 60 seconds. So generate the traffic within 60 seconds, or if you're going to take your time before you generate the traffic, maybe the application needs time to start up, then change your log time. Okay, and with that, actual second, we have everything ready. Packet filter is configured and enabled. Logging is not yet enabled, but it is configured. Packet capture is not enabled, but configured. So you can start packet capture in the GUI, but you can only enable logging in the CLI. So debug dataplane packet tag, set log on. And I like to do this separately because it gives me a minimal discrepancy from when the capture starts and when the logging starts. Okay, okay, and go. Okay, okay. Now, how do you check if you've captured traffic? So run the same show setting command again. You'll notice we've received traffic. At this point, you can stop your capture. If you don't want to use this command, you can use global counters. Show counter global, packet is. Again, ignore the output if you haven't run the command for quite a while. Run it one more time. I've received traffic. Okay, I can now stop my packet diagnostics. Debug, set off, and then off. You want to turn them off almost at the same time because that helps you when you're going to the logs. So if you let the capture run for longer than the logging or the packet diagnostics, you will end up with a Wireshark or a pcap file wherein you might have some packets which were not logged, and if you try to look for those, you'll just go crazy. Okay, so here are the packets that are being dropped. If you will notice, there was no transmit stage. We have RR, FF, and DD. So we received the packet. The packet went through the security rule processing, app ID, and so on. That's the firewall stage. But it did not reach the transmit stage. Instead, it was dropped. Okay. So what is being dropped? So these packets over here. Now, to aggregate the results of the packet diagnostics, you need to run the command dataplane aggregate logs, and then debug it in no flush. Okay. The aggregated packet diagnostic log is now saved into this file name. This file, the directory for this file will depend if you are on a device with a separate data plane or not. So devices without separate data plane, those are your 400s, 220s, 800s, 500s. So the directory for this, and the VMs as well, will be in the management plane directory. Okay. And packet. You will notice there are two files in the management plane directory with the similar name. Look for the one with an underscore between packet and diet. Ignore this one. That's not relevant. If you're on a device with a separate data plane, how do you know if your device has a separate data plane? Also hardware RP. This website here will give you the information. So 1400 series, you have CPU, 8 cores. This does not have a separate data. As you can see, the 8 cores is allocated to 2 for the management and then 6 for the data. Okay, 5400. This is the 5400 without the cards. Here you will have an FPGA, and although they have the same same share of the CPU, or the CPU is being shared, it has its own FPGA, so it will have its own data plane there. For the one with the cards, each processing card, data processing card will have its own CPU. Okay? So your directory would be dp-log. If you have cards, that will be either slot 1, dp0-log, or dp1-log, dp2, and so on, or slot 2, dp2, dp0, and so on. Okay. Okay. For us, it's going to be management. Okay. So this is the output. Where do you start looking? You start looking in your packet captures for the drop traffic. You can search for the IP address. You can search for the ID, the IP ID. You can search for any of these headers or any of these fields in the ICMP header. Okay. Although the identifier here has two formats, a BE, a big endian, and a little endian. Same for the sequence numbers. So let's start with an IP address. To search here, press if you are not familiar with less, I suggest you familiarize yourself on how to use less, because you will be using that a lot in the CLI. Okay? In the less command, you have the option to search by pressing /, and then from here you can use regex expressions. Sorry, regex. So 171.1.5. Okay, so that's my IP. In your case, if you did not have a very specific filter, you might have some noise, some noisy output. So you have to sift that through using the other unique identifiers such as the IP ID. So 64046 IP ID equals 64046. So that is packet number 1. We can also check out what sequence number it's using. Sequence, it looks like to be the short one. Yeah, the big endian format. So you can use that for your search over here. So search 1919. Do sequence 1919. Okay. So here we have the log for the packet movement within the firewall. It comes in the ingress stage. Part of the ingress stage is checking if there is an active session. The firewall did not find any active session, so it moves on to slow path stage. In the slow path stage, that's where your NAT policy lookups come up and your security policy lookup come up as well. Although take note of the numbering here, index 0 means rule number 1 on my rules. Also, if you disable that, then this will not be index 0. Index 0, if you have multiple rules, index 0 is going to be the one that's next, that is enabled next. Okay? So, undo. Cute. Okay. Here we have a rule. Okay, we have a session. So here we have session ID. Now this session ID will replace the tag number once it goes through the fast stage. Okay. Also, that session ID is useful when you go to your traffic logs and you enable your session ID column. Now I'm just looking at this specific instance of that thing. Okay. And you can also do that in CLI, show session ID. Here you have your information. Okay. Sequence. Okay. Right. So after slow path, we move on to fast path. Okay, and then after within fast path, we are looking for the we're checking for the forwarding. Route lookup in router 1, IP destination is this. We found the route, the interface is 1/2. The next up is 110. Resolve the ARP for 110. ARP pending, no response from the ARP. After some time, the packet is dropped because there was no response. So with the packet diagnostics, that's how you would be using it to gather more detailed information for why the traffic is not. Okay, but again, during the double counter stage, we already found out what we could do during that stage to find the issue. Okay, packet diagnostic is just there to give you more information if you need more. Right. Tips and tricks on how to set up your packet diagnostics. Uh, Number one, clear your previous, clear any previous setting. Either do it here or do it in a CLI. You'll notice that I did not do that earlier because we didn't have any setting. If you do not clear your setting and you run another packet diagnostic, you will have this output in addition to the latest output that you are trying to gather. And that can be confusing if you've left the file to grow over time. Okay, so always clear the settings first. You can do that here. If you want to do that in the CLI, again, it will start with the plug dataplane packet command, clear all. Okay, and then from here, the filter is gone. Captures are gone, but the resulting files, saved files, are saved. Also, our settings are gone here. Okay. Also, this file, the packet diagnostic file, will remain. Oh no, will remain. And if you want to export this, this will be available in uh, the tech support file. If you want to clear this, debug between packet clear log. Why is it still there? Yeah, there we go. It our output is no longer available. Sequence 1919. So 172.16 one no longer there. Okay. So these initial lines here are just the initialization for the packet diagnostic command. Okay. So clear your old settings. Export your tech support file so you can analyze the packet diagnostic log outside of the CLI. Be as specific as possible because, again, for a few reasons. One, to reduce noisy logs. Two, this packet diagnostic uses up data plane resources. If you've set a subnet here and you did not specify, even if you specify one destination, that's a lot of processing for a whole subnet for the firewall. So that will impact the CPU usage. So how do you know if the packet diagnostic is safe to run? And how do you check your data plane CPU usage? So commonly you would schedule this with the maintenance window during the downtime outside your business hours. To check the CPU usage, you will have the show running monitor, show running resource monitor. You have the option to specify your sampling rate, sampling rate, um, sampling rate unit. So you can, if you do not specify a sampling rate unit, it will give you all the sampling rate units, starting with the per second, moving on to per minute for the last 60 minutes, per hour for the last 24 hours, per days for the last 7 days, per week for the last 30 days. Okay. If you specify minute, last 5, it only gives you your resource usage for the last 5 days. You have averages, and then you have maximum. So how do you know if it's safe to run the packet diagnostics? Do not rely on this information alone. You also want to rely on 2 other information. The first one we've already shown you, is the global counters. Show counter global. Filter global. Yes. Okay. Oh, hold on. I'm gonna set up the filter again. No. One. Let's see. Okay. And then we have it turned on. So the next one is your current CPU usage. Take note of that, of the averages and the maximums. Okay. Next piece of information is your global counter. Show counter global filter packet. Yes. Delta yes. Okay. Again, ignore the first output. So right now, I'm generating quite low volume of traffic. So that's one packet per 0.86 seconds. Okay. One packet, 0.86. In your case, it might be different, but again, take note of the rate. Okay. Yeah. Okay. That's the second point of information. The third point of information is your overall session or packet rate term. So your current packet rate, right? My current packet rate is 176 packets per second. So we bring those three together: my current packet rate, my test device's packet rate, and then my data plane CPU. Okay, over here. So say I have the current packet rate of 176. Oh, sorry, that's not the CPU. Where's my CPU? Oh, over here. Okay. If my CPU is at 80% for 176 packets per second, if I'm going to add one more packet per second to that and perform a debug on those packets, you're getting dangerously close to overutilizing your device. Okay, if my CPU usage is at 50%, at 176 packets per second, and I'm going to add one more packet per second to that and perform a debug on that packet, um, I'm going to be still safe. So it may reach to 60%, but I definitely don't expect the one packet per second to use the rest of the 50% of the CPU, because at 176 packets per second, I'm at 50, right? So this is not an exact math or exact calculation, but this gives you an overview or an estimate of whether you are safe to run your packet diagnostic. Okay, so do not rely on one point of information. Check all three: um, global counters, current CPU usage, and your current overall session, uh, current overall packet rate using the show session info. Okay, and also as mentioned, it's always best practice if you're in a critical environment to schedule these packet diagnostics during business hours. Sorry, outside business hours during a maintenance window. Okay, all right. I would, for the final thing that I want to discuss, it's going to be a demonstration, or actually an example of how global counters will tell you what's causing your CPU usage. Here is one. So this is the output of global counters. As you can see, we have packets received, packets sent, and then if you will notice, CTD packet slow path, that has a rate of 113,000, which is almost half of the overall packets that you are receiving on the card. So almost 50% of your traffic is going through slow path. So uh, what would you check in slow path? What factors can happen in slow path that would cause a high data plane CPU? You check this chart here. So in slow path, you have forwarding lookup, you have NAT policies, and your security policies. So that means that if you have a lot of NAT, and if you have a lot of security policies, say 1,000 for each, then the firewall will take more time if the packet always goes through slow path or session setup. Question: can a packet not go through slow path? Yes, if there is an existing session. Where is it? There you go. So if there is an existing session and there is a match found, then the packet does not have to go to slow path. It just goes to fast path instead. So if what does a packet going to slow path mean? It means it is a new session. It is not. It does not match an existing session. So the firewall has to perform these tasks, these lookups again. And then the larger your rule sets are, that will affect the processing time or the CPU usage for your firewall. Okay. Where is it again? Oh, yeah. And that's how you would use load counters to check what's going on with your dataplane CPU. In this case, you do not have to set up a packet filter. You just need to use the option of show counter global filter delta S. You just have to check delta S since you're checking for the overall health of the firewall. Okay. Another example. So DFA and AHO. So same idea, right? Sadly, in this case, we did not have the packets received counter, but the same idea applies. You have the rate. Compare that to your overall packets received. Is that high and is that low? Okay. So DFA and AHO, that those are just for app ID and content inspection or vulnerability inspection. So if you see these two, that happens in the app content inspection and app ID inspection phases or stages of the packet path. Okay, and with that, that is the end for my demonstration. Do we have any questions? Hold on. Let me go here.
We didn't really have much in the way of questions, actually. Just that at one point we were getting a little bit of a high-pitched squeal from your mic for some reason on your end, but that's fine. No big deal. It happens.
Are you sure it wasn't me?
You were the only one speaking at the time, so it kind of had to come from you. But no big deal. No, yeah, the only question we had has been answered already. Alberto, you've been doing a fantastic job on that during Angelo's session here, so thank you very much for doing that. Really appreciate it. Obviously, Darren and Cindy have already dropped, but Angelo and Alberto, thank you both very much for today. Really appreciate it. Alberto and Angelo will be around for another minute or two while we're kind of wrapping things up here. So if you do have questions from in the chat, they'll try and get to them. Otherwise, thank you very much. Really appreciate it. And I'll go ahead and wrap things up here. So, yes, the event, again, there've been a couple of questions of that in the chat. I'll say it again. Yes, this event it has been recorded. Give me a couple of days to edit it. It'll get loaded up to Live Community's YouTube channel. And then we will also have it linked to a blog post on Live Community as well, where the presentations from the events, from the speakers, will also be posted and available to you. That way, especially with the earlier presentation, even Angelo's got something there too, all the links and whatnot that you were seeing in there, references to other events, all of that will be available to you. So, Angelo, thank you very much. We will let you go.
Thank you, Charles.
All righty. You have a great one. Thank you.
Okay.